Hello. In our last video, we talked about internet level protocols, the internet protocol, and the Java feature sockets and server socket classes that help Java deal with the internet protocol. Now we're going to change our focus a little bit and talk about application level protocols. So there needs to be two protocols. A protocol is just an agreement between programmers about what the program will do. The internet protocol is pretty well established, and anybody who wants to join the internet has to follow that protocol. Application level protocols are maintained on an application by application standard or basis. So we're going to look at a sample server program and a client program which enables clients to manage bank accounts. And so there's a server application and a client application, and they need to share an application level protocol. So we're talking about a simple bank access protocol that's described. So basically we're talking about these four kinds of requests. The client can say, what's the balance of account number 7111? Or I want to deposit into account 7111 $500, or I want to withdraw, or I want to quit. And the server is supposed to respond with the account number and the balance, the account number and the new balance, and so forth. So TCP/IP is the internet protocol, and it establishes the connection between two computers on two ports. And each internet application then has its own application protocol. So far we've talked about, in the previous video, we talked about how computers connect with each other, how processes connect, but we haven't said anything about how they interpret the data that gets sent back and forth. That's the application protocol. So in this case, the server waits for clients to connect on a certain port, in our case 8888. The server socket listens for incoming connections using that Java format, server socket class equals a new server socket, that port number. And then the server goes into the accept mode, and it calls the accept method, which waits for a client connection. Now, the server also creates a BankService in our example case. And the next slide will show what BankService is involved with. So BankService carries out the service on the server side. It implements a runnable interface because it needs to free up, first of all, it needs to create a BankService object for each client request, for each client connection. So basically the client service, the BankService server side class, since it's runnable, it implements run. And the run just continually goes through the loop. While there's a request from the client, while there's not a request from the client, it's done. While there is a request from the client, it calls it a command and calls execute command. So we'll see what those are in a minute. So the server executes a command. The execute command method processes a single command. For example, if it's deposit, it carries out the deposit. If it's withdraw, it carries out the withdraw. If it's just the amount in the balance, it returns the balance. And after each command, the account number and the new balance are sent to the client with that format. Then it returns to the run method. If the client closed the connection or the command equals quit, the run closes the socket and exits. So how can we support multiple simultaneous clients, because more than one person is going to come into the bank at the same time? Well, we're going to spawn a new thread whenever a client connects, and we're going to have a server, a bank server, that responds to one specific client. So BankService implements Runnable, so it can start a thread using start, and the thread dies when the client quits, or the run method exits. In the meantime, the bank server loops back again to accept the next connection, the next client. So this is the code. The server enters the accept method, and it waits for a client to connect. When a client connects, it returns this S as the client side socket, and then the bank service creates a new bank service object and called service, and puts that in a thread, and then starts that thread running. And then it returns to the accept method. So this is a bit of a complicated diagram, but it explains all the features of this lab, which originally was a lab. We're not going to ask you to do it, implement it. The bank server creates a thread reference to a socket, and creates a reference to the bank. So there can be more than one bank service. Here's BankService 2, BankService 1, and the client is connected to the bank server, but then it's handed off to the bank service, and it interacts, prints, and reads. And we'll see in our lab in a little bit in the next video how that works in a different application. So here's the bank server. Basically the code that we saw before. The server stays in the method accept, pauses there until a client connects, and then it prints client connected, and then it creates a new object called BankService and starts a new thread with that service in the thread. Then it returns to wait in accept in the accept method for the next client. So here's BankService implements Runnable, so since it implements Runnable, it has to implement a run method. We've seen this a couple times. So it creates a scanner object and a print writer object, and it calls do service, which is over here. So do service, we saw this a minute ago, looks for the client to send a result, a command, and then when he gets that command, if he doesn't get any command, if there's no command coming, then he returns out of the true out of the while loop, and the run method exits. But assuming that there will be a message coming from the client, he calls next and gets that command as a string. If the command is quit, then he returns also. Otherwise, he executes command. Well, here's execute command up top. And the application protocol are those four things: deposit, withdraw, balance, or quit. And so the client sends one of those four texts with perhaps other information. And they eventually get executed in execute command. So here's the bank account with its deposit and withdraw methods. And the bank itself has an array of bank accounts. And if you're going to deposit into a certain account number a certain amount, you find the accounts in the account number and deposit the amount. Same thing with withdraw and get balance. So here's the client code, and the client code also understands the protocol. And in this example, the client code is going to call deposit account 3 $1,000 and then return. And they're going to send that command to the outstream, or withdraw, or receive, or quit. And it's going to do all three of those things. It's not going to do balance, but that's exactly what the client is going to do. So here is the server console in Eclipse or some other IDE, and here is the client console in Eclipse. So that's an example of an application protocol. Remember, a protocol is just an agreement between programmers about how the computers are going to behave, and we need not only the internet protocol, the IP, but we also need an application protocol to tell each computer what to do when they've connected and what to do when they've sent messages to each other.